because I'm going to actually get work done because this meeting is stupid. Right.
Yeah.
I'm really excited for today's conversation. I'm joined by John Crickett. He's the CTO at a telco company, and more recently, he's shifted a lot of his focus to his side project, now turned more of what I hope will become a full-time business, codingchallenges.fyi, where he posts a new coding challenge every week, kind of newsletter style. And he's got over 50,000 students online kind of following along and doing the coding challenges every week. And I've coerced him to come onto the podcast and talk a little bit about how he got into the position that he is as a software architect. And we'll talk a little bit about the whole coding education space. I think it'll be fun. Welcome, John.
Thanks, Wayne. Thank you for having me on. Minor correction. I was architect at the telco company.
I did it again. Gosh dang it. I don't know why CTO is in my head, but yeah. Software architect.
I've been a CTO of a few smaller startups, but not of a $1 billion telco.
Got it. I think that's what it is. Okay, so you're currently at the $1 billion telco. You've been a CTO in the past. I think that's like hanging into my head from some bio I read somewhere. And for those listening who might not know what a software architect is, it's a very senior kind of developer title. Can you explain what a software architect is?
You know, I struggle at times because it means so many different things in so many different companies. You know, in some organizations, it will be very hands-on, and I've done that very hands-on, being involved in code. In one organization, it was entirely a management role. I led a team, and I had no hands-on involvement. And more recently, it's been very much kind of looking at the architecture, looking at the infrastructure, looking at the impact of different things, and looking at that cross-organization impact. So what are things like GDPR going to affect us? How do different telco laws affect us? What do we have to do for privacy, security? What can be applied across the organization to benefit from doing the same things at different scales. So it's a wide variety, but it's generally a bigger impact than just your team and looking at how you contribute across the organization.
My career over the last 8-9 years, I went from junior developer, mid-level developer, senior developer, and then I kind of started doing people leadership. So team lead and then manager of an engineering team. I was still very technical, on the engineering side, but the leadership part of my leadership was, people oriented. And my understanding is that this whole other branch, especially when you go into larger companies, because to be fair, again, as team lead and manager, I was technical leadership and people leadership. They were small companies. At larger companies, my understanding is kind of branches off and you can go into people leadership. So manager, director, CTO, or you can kind of take this other route, which is more focused on technical leadership, which my understanding is staff, developer or staff engineer, architect. Is that kind of how it works?
Again, it's varied across different organizations, but yes, that's certainly in my last role. That's very much how it's been worked. The architect was, moving and senior thing. They had a split track, so you had management roles, as you say, director, VP, and so on. That was entirely people management. They then had a individual contributor track, which again split between architecture, so focusing on, how do we architect this thing? How do we get commonality across systems? How do we have that cross-team and cross-organization collaboration? And then there's very technical hands-on people who are also senior and staff principal, but more focused within a team or within a small area.
So you're making a lot of decisions that kind of have sweeping consequences across the organization, I would imagine. Are you choosing things like what programming languages, what frameworks, what databases, what communication protocols? Are you making decisions around what the rest of the team is going to be using?
So I think that's the interesting thing with architecture. If you do it right, you're not really making the decisions. You're providing guidance, you're providing a direction, and then you're trying to influence without authority to get people to buy in. Because at the end of the day, the team that's going to build something has to own it, has to have some say. If you just tell them, you will do this, and you're a bunch of code monkeys, and you just got to write this code, nobody wants to do that. They're not going to buy in, they're not going to be involved, and it's going to suck. You're not going to retain the staff that way. So at that level, your architecture is very much trying to provide guardrails, some guidance, some of, shall we say, the grey beard of, these are some of the things to look out for and to consider in your decision, but you've got to leave the teams to actually make the decision or they won't have a sense of ownership.
So do you do a lot of what this is the cringy, maybe businessy LinkedIn way to say it, but do you do a lot of thought leadership? Do you publish blog posts and write big long essays to the org. Like, how do you get buy-in on this stuff?
Yeah, it can absolutely be like that. There's a lot of times in that role where you're writing effectively an RFC. You're saying this is how we think it should be done. This is what we believe is the best solution. This is what we recommend. You should do this, and if you do it, you'll get our support. If you don't do it and you go wrong, then it's on you. So it does veer into that kind of ivory tower architecture, which I personally don't like.
Do you prefer the technical side of leadership? Have you done like the more people focused, like engineering manager, director type leadership?
Yeah, I have. I've been a VP engineering in a startup, and I've been a global head of engineering for a fairly large corporation as well. I like both sides. They all have their challenges, and at the end of the day, it's overcoming the challenges and figuring out how to get things done that excites me. And if that's technical, that's awesome. If it's people, it's also quite interesting. If people are more challenging, we're computer's very logical. You say add 2 + 2, the computer's going to give you 4 every time, and it's pretty consistent, and we can reason about it more. Where people, we're all different. We have good days, we have bad days. The same person we behave differently. We can get ill and be off color like you are today. We can be having a great day. So it's all very situation. So it's a lot, I think, harder in some ways, but it makes it more interesting and varied.
I always assumed, so like, I mean, to be clear, especially like when you're learning to code, like coding is technically challenging and software architecture is technically challenging. These are like hard skills that you do have to put in a lot of work to learn. But once you've been doing it for like 4 or 5 years, it's not to say that it's never hard, but I completely agree with you that like once you've been doing it for a while, the challenges are like for the most part deterministic is maybe the word I would use, or more deterministic. It's like I've seen this before. I know we can introduce this technology and we'll have this sort of an outcome, or I know that we can change this for loop this way and all of a sudden it'll be a lot faster. Whereas with people, I always thought that I'd really enjoy being again, to use the cringy word because I don't know any other, like a people leader, and it's actually like the hardest thing ever, and I don't really like it. Fewer direct reports makes for a happier lane, is what I've learned.
Yeah, I think even then it depends, because if you've got the right team around you, it can be a lot of fun and it can be quite relatively easy. If you've got the wrong people around you, it can be an absolute nightmare. I've had times when I've really enjoyed it. It's been a great bunch of people. It's been a great vibe, and we've done some amazing things. I've had other times where I've joined companies and I thought, "What the hell have I done? I don't want to be here. This is not the organization. It's not the people I want to work with," and it's been a nightmare.
So tell me how you got into all this coding stuff in the first place. I mean, we heard it from you. You've been CTO, architect, VP of engineering. Like you've done all this stuff. Where did it start? Like, how did you first get into coding, and roughly when was that?
I think I was about 6 years old when I first started looking at coding. Must have been about 1982, 1983. I can't remember. It's too long ago to remember exactly when, but
6 years
at the
old. That's
time,
incredible.
yeah, at the time my family lived in Brazil. My dad had taken a ZX Spectrum out there. I think with the belief that it would be educational. There was some educational games on there, and I might learn to be better at maths with it. Instead, it was something I played with, and I started learning to code a bit in BASIC. Then I came back to school in the UK at the age of 9. I was at a boarding school. My parents were still living in Brazil. The school had BBC Micros and Great Big Fig Basic Manual. So I led that, and I had dreams of creating artificial intelligence on a BBC Micro at 9 years old.
Before neural nets had even been a buzzword on LinkedIn. Yeah.
Yeah, so it's, wildly optimistic, but, that's what you like when you're a kid, isn't it? So I had a lot of fun with that. Wrote computer games there, eventually progressed to a Commodore Amiga, wrote some more computer games than that. Worked with a few friends throughout high school and so on, playing with that. And then in 1995, I went to uni, and during that time, the internet started to really take off and become quite common. In summer of '96, my first summer holiday from university, I ended up working for one of the UK's first ISPs. I literally actually went for an interview on the help desk. So again, this is one of the things I tell people a lot on LinkedIn. You don't have to get into software engineering by landing a job. Try different ways. So my first year at uni, my parents had seen an advert in the local paper that this internet service provider in some rural village in the UK, a place called Shepton Mallet, was looking for people to work on the help desk. I applied for that. I turned up for the interview, and I was in an absolute state of hay fever. My eyes were watering. I was unintelligible.
Oh
I was
no.
sneezing every 30 seconds. And the guy, kind as he was, just looked at me and went, "That's just not going to work. You can barely talk to me now. How are you going to answer the phone all day and speak to people?" He said, "Yeah, but thanks for coming. And tell me a little bit about yourself." And I said, "I was at uni studying computer science." He went, "Much you could do with another programmer. Can you write code?" And I said, "Yeah, sharply." So he took me next door. I met the one other programmer in the company, and he said, "Yeah, actually, we could do with some help for the next couple of months. We've got a few projects coming up. Can you write C?" And I was like, "Well, we spent one day writing C for work experience." So,
So
okay,
yes.
cool. Yeah, cool. If you're game for giving it a go, we'll come and try you out for a couple of weeks. So I then spent 3 months of my summer holiday working for them, writing CGI scripts. I learned Perl on the job and learned a lot more C. I wrote some of those horrible old web counters that if you've been around the web in those days, you may have remembered all the horrible graphics that web counters people had at the bottom of their page. You'd hit F5 and they'd refresh, and the kind of things you saw in the really old Sandra Bullock film, I think, was it The Net? And yeah, I learned Perl there, and actually learned about databases. And the guy that interviewed me, who was the head of help desk, was actually a absolute database nerd, and he taught me all about database normalization at the time. So it was a real education, and that's how I got into professional software.
Wow.
So if you want a job in software, have hay fever and apply for the help desk.
So you applied for the help desk position. You didn't actually get it. You kind of got trolleyed over to the other building where they gave you a programming
Which
position.
is where I'd actually much rather been anyway, so it worked out brilliantly.
Yeah. I've talked to a lot of people on this podcast now. I think this is going to be like episode 50, 52 maybe. And one pattern that continues to surprise me, because I didn't assume it was the case, because I don't know why, like nobody talks about this online, but so many developers got their start at like some weird, not sexy tech company kind of writing code. Like, for example, my first job, I wrote some code there. Like, that was why I applied. It was a programming position. I was the only programmer in the company. I was working with like a bunch of electrical and mechanical engineers. I was writing like little Python scripts on a Raspberry Pi, doing like little one-off things. That was the job that was available to me. And after a year of experience there, now I've got Python and Go developer on my resume. It was so much easier to move into like, sexy tech companies or whatever. Now, I'm not like trying to discourage anyone from saying like you can't go start at Apple or whatever. Like I understand that that's obviously possible. Plenty of people do that. But I've just been amazed at how many people their start was through some company they were at for like a year or two. And it wasn't sexy. It was like a small company. They wrote a little bit of code and, it got something on their resume.
Yeah, absolutely. And I've had the same experience. I've met people who, they worked for a printer, and the printer decided that technology moves on. They decided they needed a bit of code writing. So they ended up becoming a software engineer because the printing press was more automated. They didn't have too much of work there, but the company now needed somebody to write software. So they just kind of drifted into that. That ISP was an education. The people that worked there, one was a professional juggler, one had been a journalist and ended up writing code for that, and a couple of those people actually went on and worked for Amazon later. So they'd gone from juggling and that kind of thing to some random little tiny ISP startup in the UK that incidentally went bankrupt while I was there, so that was quite interesting, to eventually ending up working for Amazon and doing some fairly major work for them. So
I've never heard of the juggling transition before. That's a first for me.
Yeah, it was new for me too.
I've heard a lot of like music and education, like teachers and people with music degrees or whatever switching into code. Professional juggler though, that's pretty interesting. I imagine it's one of those like very much like sink or swim careers where either you're like on stage in Vegas 5 nights a week, or it's like really hard busking on the corner.
Yeah, I don't have the skill for that, so I've never tried that one.
Yeah, me neither. I've tried to pick up sidebar on juggling really quick. I can do the one-handed 2 items, two-handed 3 items. I can do the two-handed 4 items for like 5 seconds. Like I kind of understand the technique, but I've never practiced enough to be able to do it for a long time. And I don't understand how people get n equals 4 is a cap for me. And I've watched people like do 13 and it's just absolutely insane. I don't know. Like
it's amazing, isn't it?
Seems like a step function of difficulty. Like I don't know how you get there. Okay, cool. But now you're here and you started building coding challenges. So tell me a little bit about the impetus behind coding challenges. Tell us A, what it is, because I've probably butchered it a little bit, and then B, why you started it in the first place.
So coding challenges is a newsletter and website with a bunch of what I've called coding challenges. which is perhaps a mistake. I mean, the name sounded great for being an alliteration, but now most people confuse it with being something like LeetCode and being very focused on interview tests for people, which it's not. It's a weekly newsletter and a website with a collection of the past issues, which provides real world projects that you can use to become a better software engineer. So I've always believed that you become the best software engineer by building code. It's like if you want to learn to play guitar, yeah, you can read a little book and you can learn a bit about them, but you're never going to become a guitarist by reading a book about it. You can't become a guitarist by watching a video about it. You have to actually pick up the guitar and play it at some point. I believe the same applies to software engineering. You can read a book, you can watch a video, you can get a certain amount from that, but you actually have to get a computer out and you have to build software to really understand it. And that has to be more in-depth software. You actually have to build something that has some depth to it to really learn to do it. So these are projects that I've used over the years to either learn a particular technique or to learn a programming language. So when I was at university, we learned about Huffman encoding and various different data structures and algorithms. When I wanted to get a bit more in depth in C, just after I graduated, I had a little bit of time in the work where I was working for a company where you were on charge for customers, and I had a couple of weeks when I wasn't on charge and I had nothing to do. So it's like, sit in the corner and teach yourself something useful. So I decided at the time to get more in depth on C. So I ended up, I've read Michael Blash's graphic programming black book, which was quite popular at the time, which had a lot of stuff about optimization in it. I wanted to learn a bit more C and get better at C. So I thought, okay, I'm going to have a little play with Huffman encoding, and I'm going to optimize the hell out of this so I can compress text files as quickly as possible. So I ended up doing that coding challenge, and I've done it subsequently in different languages to learn it. And I've done different exercises like that, trying to build something real. So sometimes it's been like chat programs, sometimes it's been a network protocol and implementation of something. And I've been doing those for many, many years. In March last year, in 2023, I started discussing this with somebody as I was learning Rust. And they sort of suggested, well, you should share some of these with other people who'd be interested in them. So I'd also been keen to have a little bit of play, kind of figure out newsletters and Substack. So I thought, I'll give it a go. I'll put them on Substack, start sharing one weekly, and if I get 1,000 subscribers by the end of 2023, it'll be a fun little experiment and maybe useful for other people. So I announced it on LinkedIn. I think it was like March the 11th, and on a Friday, by the end of the weekend, 1,600 people had subscribed.
That's amazing. Did you have a pretty big following on LinkedIn at the time?
I had 4,000 followers on LinkedIn at the time.
Nothing like I mean, that's a lot, but it's not crazy. Like,
No.
certainly I wouldn't expect you to immediately get 1,600 subscribers. That's awesome.
I was blown away by that. So then I just kept writing them, sharing some of the ones I've done in the past, sharing some new ones. And at the end of the day, I like writing code, so it's been really fun to dig into them. I've had a lot of suggestions, and people have reached out with different things they want to do. Like a couple of weeks ago, I did Docker, which was quite fun to really dig into. What does it take to build a container runtime? What does it take to pull an image and unpack it and then execute it? So I've had a lot of fun doing those things, and it's been a great learning experience for me. And it's just grown up since then. It's now a little over a year old. And as you say, 50-odd thousand subscribers on Substack. There are 80-odd thousand subscribers on LinkedIn, and the website's getting about 40,000 visitors a month. So it's become quite popular.
That's awesome. Yeah, it's almost like coding projects versus coding
doesn't quite sound
challenges,
as good. Doesn't have the alliteration.
Oh,
maybe I should have done programming projects.
Yeah, I'm a huge fan of alliteration. I will break all sorts of rules to get that. Like our mascot, his name is Boots. We teach backend on boot.dev. The podcast is Backend Banter. Huge fan of the whole alliteration thing. You said something really interesting there. It was like way at the beginning where you said you were at work and you had a bunch of downtime, and so you spent that time where you would have just been sitting in the corner, like learning C. And we've talked a lot on this pod about remote work and the nature of remote work and like what are the good things and what are the bad things. And generally speaking, I'm a huge proponent of remote work. At BootDev, we're all remote. But I do like to point out the things that are disadvantages when I see them, because it's important to understand the disadvantages so that you can, in a lot of ways, like try to mitigate or compensate for them. And this is one that I'd never thought of this before, but I've been in a lot of jobs where I had to like be there from 8 to 5 or whatever, right? Like when I was a teller, and I had to be there. Like I had to be there. And, there would be an hour where it was like really slow and there was like not a lot to do, but I had to be there. And it was a really nice, like forcing function to like get me to do something else, like my homework, because I was in school at the time. Or like you said, I've had jobs where I had to be in my chair from 9 to 5, but like there just wasn't a ticket to work on at the moment. And so I could like study something or do coding challenges online or whatever. It just got me thinking, like, that's not a thing with remote work. Like with remote work, if you have nothing to do, you're not forced to do anything. And I mean, there's something nice about that, right? It means you can take a break or whatever. But it also means like you're probably going to get a little less done. I don't know. I never thought about that before.
I think that probably depends on your motivation and how engaged you are with what you're doing. I've been remote a lot since 2017, and I've always used those kind of moments of downtime as still like I did back then, that they're a chance for me to go and, I've got a massive backlog of reading. They're a chance for me to do a bit of CPD. And so I've got lots of YouTube videos. I've highlighted different conference talks, or I'm a big reader, so I've always got a big stack of books. So just as I did back in 1998, I've still view those as a chance to grab something off that backlog and read it, watch it, study it, build something, and learn about it. I think it would depend on your motivation. Maybe for some people that will work that way, but again, I think for a lot of software engineers, a lot of us are in it because we're curious, we enjoy this. So if you've got that time without ticket, a lot of us will naturally do something to go and, oh, I want to learn about this, or we'll go off and I want to learn Rust, I want to learn Go, I want to learn about Kubernetes or whatever. So we'll go off and we'll find a way of filling that time. Maybe not always for the best, because sometimes we'll build something cool and then we want to use it. And maybe we shouldn't be using it because it doesn't fit the rest of our team. But I think a lot of us are naturally curious and we'll feel that positively.
Yeah, I hope so. I don't know. Like I find myself scrolling TikTok sometimes, and I definitely not happy with how I spent the time. Now that I think about it even more and hearing what you're saying, it might just not even be a thing in 2024 anymore, because I'm thinking like 2009, 2010, 2011, I didn't even have a smartphone. There were a lot of times where I was like forced to be somewhere without a smartphone, without internet. And yeah, like the only thing to do was like read this textbook, right? The only way to like stimulate my mind at all was to do something semi-productive. But now, even if I am in an office, right? It's like I've got internet. Like I can zone out in front of YouTube or TikTok or whatever. So I think like what you're saying is even more true, where it is more just, especially in 2024, where you don't go anywhere without the internet in your pocket. It is more just about having good motivation and like discipline if you do want to get stuff done that's useful.
Yeah, I've actually noticed in my most recent role, I've noticed a different problem with remote work. So I've always been a huge advocate. Again, I live in rural England. It takes to any major town, it's about an hour commute anywhere. So I enjoy not doing that commute. I'm quite happy not doing that commute. And I particularly never like to commute to London again, because that's just, the public transport is abysmal and it's a horrible experience, particularly in summer. But in my most recent role, I've noticed a problem with remote work, which I haven't experienced before, in that if you haven't got the right culture, it's very easy, as you say, for some people there to kind of zone out and say, well, yeah, it's not my job. And I've noticed, particularly in cultures that don't have the kind of live chat and deal with everything asynchronously, it's very easy for people just to blow things off and behave in a way that they wouldn't do if you were walking down to their desk in an office. If you wanted something done in an office and all that, you could walk down to somebody and say, hey, how are you doing? Good morning, good afternoon, whatever. Can I talk to you about this? You'd have that normal human decency. But I found that more recently, when people are asynchronous and it's entirely Slack or Teams or whatever, there's no face to the name, it's very easy for people just to be disengaged, not care, be a bit more jobs worth, and get away with behavior that is perhaps more appropriate and more commonly seen on things like Reddit than that you would get in an office when you're face to face. That's been a bit disheartening for somebody that's a big proponent of remote work.
No, in my adult life, so like I'm a fairly extroverted person, especially probably if you compare me to like the world of developers as like a baseline. When I was in school, particularly high school, because when I was in college, actually, I was spending a lot of time with my wife. I didn't I didn't actually spend all that much time with friends. But like in high school, I spent a lot of time with friends. And as an adult, especially post like university, almost all of my friends have come through work. It's like the only place I meet people. I have my wife, I have my family, my extended family. I have friends from high school that I see occasionally. They're amazing, but again, I see them like once a year. My friends are now like the source of new friends has just been work. I've noticed this kind of phenomenon that you're talking about, where in remote work, you have to try really hard to like become friendly with coworkers, because it is more like this online relationship where you're text chatting with someone, maybe you're hanging out on the same forum. And like I said, boot dev were fully remote. A startup I was at a couple of years ago during COVID was also fully remote. And the thing that has been most impactful for me so far has been getting everyone together physically for some number of days. Like we're doing a retreat here in just like a month where we're flying everyone to Utah. We're just gonna like stay in an Airbnb together for a couple of days and like go on hikes and I don't know, play Nintendo Switch together or just kind of hang out. But really the purpose is just for everyone to get to know each other on a very personal level. So there's like this human connection, not just a work connection, right? It's not like, oh, there's Sarah, she helps me deploy the code, right? It's like, oh, there's Sarah, and I know a little bit about her life, and I know a little bit about her relationships, and I have a lot of empathy for what's going on in her life, right? When she's gone, I understand that like, oh, she has this very particular hobby, so when she comes back, I can ask her about it. A lot of that kind of talk is lost unless you do something to bring it back. Again, like I'm not saying remote work is bad. Being aware of some of the disadvantages, you can do things, I think, to make it more enjoyable.
Yeah, absolutely. And I'm a huge proponent of the remote work, but you've got to put that effort in. You've just like you've got to create the right culture in an office. You've got to engage people and you've got to behave a certain way. If you're going to work remotely, you need the same thing. I think getting people together is essential because you need that. We need that human relationship. I am totally introverted. I don't like being in big groups of people, but I still like people. I still actually, it's so much easier and put a face to the name and talk to people and have a conversation and ask how you do and express an interest. Like you just said about your wife, and it almost sounded as though you kind of got married at 16 there. I'm curious now. I want to know that. And how you said your wife at school, like how young
Not
were you
in
when you
not in
met?
high school, in university. Yeah, we met when I was 21, and then we got married when I was 23. So we got married just 2 years later.
Okay, cool. So yeah, it's getting to know that about people is so important. And if you don't make the effort to do that remote, I think you're setting remote up to fail. Remote is great, but you've got to put the work in, just like you have to in the office to create the right culture and the culture that you want and make it work.
Yeah, it's nice to think that everyone treats everyone great all of the time. Right? Like you treat your friends the same as you treat strangers, the same as you treat random people on the internet, but like it is just not true. Especially like as we've seen, I think there's a whole Black Mirror episode or maybe even a full movie about this. Like when you interact anonymously with people online, people are assholes. They're way worse than they would be in a face-to-face interaction. Even with people you know, I'm fairly confident that I've read about a phenomenon where you're more likely to be like polite and kind when you're interacting face to face than when you are even just over a phone call or over a text message or something like that. Having to actually look someone in the eyes and interact with them forces you to like go over the top and like avoid confrontation and be a little nicer.
I think you also get that feedback as well because I can see your face now, I can see your reaction, and if I said something that offended you, you react very, very quickly, and it starts showing your face quite quickly. Where when we're doing it asynchronously over text, and you've not got that body language feedback, you've not got that person's interest, you've not got the eye contact. And what really struck home for me with this is a few years ago, I was working with a company and I responded to an email with just the word yes. I was just busy. Somebody asked for if we could arrange a meeting, and I said yes. It was just because I wasn't really thinking, just rushed it off. 5 minutes later, I got a call from the COO. Hey, John, what's going on? You've really offended X. He's just been on a call ranting to me. He's really upset. He's not in the office today. I haven't spoken to him. And then realized my only interaction in this email where I just said yes. Long story short, it turned out he was having a really bad day. He'd been quite frustrated by something. He really just wanted to rant about something. And I had missed the signs in his email, because it's very easy to do in text. And he was just looking for a bit more empathy and support. And again, like I say, I was in a rush, so I'd hammered out the email quickly. And that it's very easy to have that miscommunication. And for him to lead way more into it than was there, and for me to completely fail to lead the concern that was in his email, and you have that miscommunication very quickly, and something that was really, really simple and silly kind of escalated quite a lot. And we had a good laugh about it later over coffee, but it was one of those things where it's so easy to get that wrong when you haven't got that feedback.
Yeah, that tone is so important. Like when you just told the story, right? The way you said it was yes. It's like that sounds great. Like, you're obviously not mad. I can hear it in your voice. Yes. But then, like, you see yes on an email, and it could very well be interpreted as yes.
Yeah,
right? Like,
it's
yeah,
totally going to be the
you
mood and
idiot.
perception you have when you
yeah.
read that email.
So this is some. Now I'm gonna say something that might even be a little controversial. We'll see what listeners think in the comments. But there's this meme out there. I think it's funny. I think there's truth to it. But it's this idea of like, why did we have a phone call when this could have been an email? Or kind of the more extreme version of this is like, why do we have to have our cameras on during a phone call? I just want to be audio only, so you don't have to see me. First of all, I get that a lot, and or I should say, like, I fully sympathize with that viewpoint, and a lot of meetings should be emails. It isn't always necessary to have a camera on. I get all of that. But I think it is very important to acknowledge a phone call does communicate more information per word than a Discord DM or a Slack message. Doesn't mean you always need the call, but like, when you do want to communicate more quickly in a synchronous manner, phone calls do have a purpose, and they are very useful for that. And you can avoid all of these emotional conflicts. Same thing with video, right? Just being able to see someone's face, you get a lot more empathy comes through, a lot more information is transmitted per second. Doesn't mean you always need them on, but I feel like that's important to acknowledge. I see a lot of people getting upset about that sort of thing.
That's an interesting one. I wrote a post about this on LinkedIn about 8 months ago, I think, and I was quite critical of a manager at the time that said, we're not getting enough engagement. We need everybody to have their videos on in meetings. And I thought this was a huge mistake, because the reason there wasn't engagement is that the manager was misleading the room. It was misleading that their meetings were ineffective. Their meetings were poorly structured. There was no agenda. They were just talking at people like this, and it was really, really boring. And everyone had their cameras off because they were just there going,
because I'm going to actually get work done because this meeting is stupid. right?
Yeah.
Yeah.
It's like, the problem is not the cameras being on or off. The problem is that you're running an ineffective meeting. Read the room. And you're just going to put everyone on the spot now, as they're all there going to be pretending to be interested and pretending to care and pretending to be engaged when they're not. There's two sides to that, and you've got to. I think it's much as I'm an introvert, and I quite often would prefer to have my camera off and be able to get my head down, or I have a standing desk. It's quite often wander around, so you'd end up with me not there, but I'd be listening on the speakerphone on the headphones. So many ways I prefer it, but you have to read the room. You have to get that feedback, and it has to work both ways.
If not having cameras on is the biggest problem with your meetings, you probably have really good meetings, right? Like that's the way I'd put it. It's like, if you have short meetings that are to the point, everyone that's there understands why they're there, and like, they wouldn't cancel the meeting if they had the opportunity to. It's like, the last problem is like, we could get a little more out of this, right? We could get a little bit more empathy. We could get to know each other a little bit more by having our cameras on. Like, I'd say that's great. Yeah, absolutely. Like, I've been on those, like, because here's the thing, it's important for a lot of our listeners to understand the context of where we're coming from. I've mostly worked at startups, so my meetings are like 4 or 5 people where everyone's engaged in the meeting and everyone's talking. But I've worked at larger companies as well, and those meetings where it's like 400 people are on the call, nobody even knows that you're there, right? Like, the CEO is just kind of talking on stage or whatever. I hate having my camera on for that, because it's like, why? Like, nobody sees me. I'm like on page 17 of the Zoom call. I can get some work done while I'm listening to the announcements that frankly could have been an email. So yeah, I think there's a time and a place for both, similarly to like phone calls versus Discord DMs.
And they're all tools. Like all these things, every tool has its use. Use it the right way, they're awesome. Use it the wrong way, and they can be a complete pain in the neck.
Okay, I want to circle back now to a discussion that we kind of like very briefly touched on maybe 10 minutes ago, which is doing LeetCode versus building projects, particularly in the context of, I'm trying to upskill for a programming job. Can you tell me a little bit about like what advice you would give to someone they feel like they know how to code? They're like on the job search now, but they're not like a super senior engineer. So they still need to like upskill as they're looking for a job, so that week by week, as time goes by, not only are they getting kind of more bites with their resume, but they're also getting better and better at the craft itself. How do you think people should think about this distinction?
There's 2 sets of skills at a very high level that you need as a software engineer. One is getting the job, and one is keeping the job. And I think keeping the job is, it's having those soft skills to be able to get in a team and work in a team, because nobody builds software on their own anymore. We're pretty much all going to work on a team. Most of the team's going to be several people, and you're going to interact with adjacent teams or with other parts of the business. So the skills to keep the job are the soft skills, and are to be able to do the work and build real software. And that's the whole diverse set of experiences that you don't get from reading a book, you don't get from building a little example there, you don't get from solving a LeetCode problem. You get from building real world software. So if you're going to job, that's going to be the main way you get experience. If you want to learn a new technology or want to learn a new programming language, then you need to find something that's a worthwhile project that fits it. And that's what I built coding challenges for. That's what I think it's a very, very good fit for. So like I said, I used it to learn Rust. I've used some of the things to learn C in the past. I've got people who are doing them now in Java, Go, and whatever to learn those languages. Then there's getting the skills for getting the job. And that is being able to interview well, being able to, for the places that do them, pass the system design test. For the places that use them, be able to do a pair programming and coding exercise. For the places that use them, be able to do LeetCode. And that's a very different skill set. And that what concerns me most is I see a lot of posts now, particularly on social media, of people who have done 1, 2, even 2,500 LeetCode problems. Now, I think doing the LeetCode is quite useful for very, I don't want to say abstract, that's probably the wrong word, but for a bit like solving a Rubik's Cube. It's teaching you a set of skills. It's teaching you how to use algorithms. It teaches you some problems, which are great skills to have in life in general, not just as a software engineer. But it's not what you're going to be doing in the job. You're not going to come into a job and be asked to solve twosome. Most of the time you're going to be, and we joke about it, if you're a front-end dev, you're going to worry about things like, how do you center a div? How do we sort out this font? How do we make this responsive? If you're a backend guy, you're going to start worrying about, how do we build this API? Should it be a REST API? Should we use gRPC? And you're not going to be worrying about the kind of DSA as LeetCode goes. And you're not going to be inventing algorithms. You're going to use what's in your standard library. You're not going to be re-implementing a binary tree. You're going to use the solution that's in your standard library.
If you have a standard library, OCaml.
I've never used a camel. That's one of the few I've never experienced. Maybe there's a few circumstances like that where you don't get that, but
I'm mostly kidding. There's a breadth of amazing libraries in OCaml. Some languages do have a more rich standard library than others, but like what you're saying is absolutely correct. You're not writing quicksort from scratch. I've yet to work at a job where we're using a technology that doesn't have a built-in sorting algorithm that's like at least in the top order of efficiency, right? Like I've definitely never had to go below that direct implementation. Just use it. It's really fast. I'm sure there are jobs out there where you have to do that kind of optimization, but they are very few and far between, especially in the web world.
Yeah, and again, most of us wouldn't have the skill. If you take our standard library in, say, C or C++, the people who've implemented that library have optimized it. If you're working on, say, the Intel platform and you use Intel's compiler, Intel have built the compiler, they've built the CPU, they have implemented that, not just the most efficient algorithm, but the most efficient implementation on their CPU. You are not going to beat that implementation. So you want to use what's in your library and leverage your tools and apply your expertise at a higher level.
I agree, but I'm going to throw in an anecdote. I did have one particular story that's kind of fun. I was working on this service. This is back maybe 4 or 5 years ago. It was a Go service. And part of the service was we had to store in memory millions of timestamps. It was kind of this caching thing. We had to like store these million timestamps, and occasionally we'd like, delete the old ones, bring the new ones in. We were using them for like, it was basically caching. I'll leave it at that. Point is, millions of timestamps in memory in RAM. This service was using like 40 gigs of memory in RAM, which was not great because we're running on Kubernetes. And so anytime we spun up one of these pods, it had to go on like the one node that actually had that much RAM, and it caused scheduling issues and things got really slow and clunky. So long story short, I got assigned to work on this thing. What I found was the Go standard libraries time.time struct takes up quite a bit of memory because it has like all these great features. I'm going to butcher it. I think it's nanosecond precision off the bat, and it has time zone support built in. And so if you're using all those features, it actually allocates quite a bit of memory. So I just spent like a day and built a library, another time library that used the exact same API as the time.time library, but only used like 4 bytes of data under the hood instead of the 32 bytes. Memory came down to like, I don't know, 8 gigs. It was something crazy, like, almost 5 to 10x less memory was being used. And the only reason I say that is like, this wasn't like the hardest thing in the world to implement, right? Like I was basically just storing dates instead of using time.time, but it comes up very occasionally. And I think my whole purpose of telling this story is just to say, I'm with you. I'm like, grinding LeetCode isn't what allowed me to do that. But at some point, learning a little bit about the underlying fundamentals, right? About how memory is stored on a computer and doing that once or twice and then going and building a bunch of projects. That's kind of the approach that I take to these things, because I do also like to push back on the whole idea of like, I'm just going to hand wave and let my framework take care of everything, because you can get stuck in situations where you don't understand why your service is so inefficient.
That's a great example of when you want to go that next level lower. I've seen this with some of the coding challenges. A lot of developers nowadays, I was having a conversation the other day, somebody thought Stack Overflow was a website. They've never heard of the term. They weren't really familiar with the idea of a stack or the heap. And that's now, when I started coding, every software engineer knew what they were, because you couldn't avoid it. We're now further levels of abstraction away that an awful lot of software engineers who aren't familiar with the concept of stack and heap, and they don't know that level. So I think that's one of the problems for people, maybe like you and I, who have been on this a bit longer, that it's sometimes easy to be, or to forget, not realize what junior developers these days don't know because of that layers of abstraction. So things that we're aware of. Again, I've seen this with coding challenges when some of the challenges are to recreate some of the Unix command line tools. And I had several people reach out and say they didn't know about man pages on Unix. Now that's not particularly a complex software engineering thing. It's just that was the only documentation on Unix when I first started writing software on Unix. You couldn't get anything else. So it seems obvious to me, but then you realize that there's an awful lot of people who've never experienced that.
That's funny, because like when I came on the scene, like learning to code, I think I seriously started learning to code around 2009 was when I like really started like actually building stuff. I'd like messed with HTML and CSS and JavaScript before that, but like actually building programs in like Python and Go and C. It's about 2009. And even by then, I learned what man pages were. I had a professor that was like pointing it out, and I was like, I can just like Google grep. Like, why do I need this man page thing? But it's one of those things that like you just, I guess what I'm saying is, even back then, the professor was like, you gotta know what a man page is. Like, everyone knows what a man page is. And yeah, in 2020, I think there's a lot of people that just simply don't.
Yeah, and I see the same with the Unix command line tools. People don't know that those are there, and they're incredibly powerful. You can chain them together and do a lot of really useful stuff.
I have been happy to see, and maybe this is just my corner of the internet, but I have been happy to see there's a lot of, especially like some of the like Twitch streamers that do a lot with code, like Primogen, Bad Cop, talking a lot more about some of this lower level stuff, like reading the manual, using grep, sed, awk, piping stuff together. Like, I love that there's this cool factor that's come back to like working with the command line and using text-based tools. Not because you have to, because like clearly there are lots of graphical user interfaces to a lot of these sorts of things, but because it is very effective when you learn how to do it. And like I said, it's almost getting this new branding that wasn't around when I was, coding in the early 2010s. Like, it's actually really cool and sexy to use the command line. It was definitely looked at least at my university, as like the old school, uncool way to do things. And, oh, I'm using NetBeans. I'm so cool, right? Like, I'm using this like fully fledged IDE. Like, that's the new cool way to do things. And I like that that's not necessarily the cool thing to do, at least in my corner of the internet.
I think I've seen it a few times where you've had new developers come in, they're very excited about their idea and it's got these great features, and it's like, okay, now go onto the prod box, and they get on the prod box and how do I do anything? It's like, well, the reason we're going to use Vim is not because I like it. Sorry to all those people that do like Vim, passionately don't like it, but it's on every Unix box. So if I go into production box and want to do something, I can get it up. And again, all these command line tools, if all you've got access to is SSH to prod or something, knowing them means you can do an awful lot on the box without having to pull back gigabytes of log files. So they just make your life easier. It's worthwhile learning the tools.
For our last topic of conversation, I wanted to talk about a recent LinkedIn post you had. By the way, anyone who's listening, if you don't follow John Crickett on LinkedIn, first of all, as many of you know listening to this pod, not the biggest fan of LinkedIn. I'm more of a Twitter guy myself, but there are a few good people on LinkedIn sharing interesting stuff. John is one of them. Recent post on LinkedIn about programming languages that do not scale, or rather, programming languages do scale. It's usually something else that's not scaling. Can you tell me a little bit more about what you meant in that LinkedIn post?
Yeah, sure. I've had so many people over the years, even going back as far as 2002, 2003, tell me this programming language doesn't scale, that programming language doesn't scale. And back in 2002, 2003, when I started using PHP, our PHP won't scale. Well, then Facebook came along and built, we could call it a moderately big website with PHP. They've moved on to Hack now. Then you had 2005, 2006, Python doesn't scale, but then YouTube built a big site with it. More recently, you've got Node, TypeScript, and I think Stripe have built a lot of stuff in Node and TypeScript. Shopify have done a lot in Ruby. 37 Signals have built Basecamp and all their stuff in Ruby on Rails. And they created Ruby on Rails. So keep seeing these arguments over and over that this programming language doesn't scale, this programming language doesn't do that, whatever. And they're all tools, and I've worked in quite a number of them. And what affects scale more than anything else is your architecture. What programming language you use. Yes, if I'm going to build a high-frequency trading system, I'm not going to build that in Python or Ruby. If you want ultra-low latency systems, it's just not going to be like you are going to need a compiled language that is performant. But most of us aren't doing that. Most of us are dealing with things where the latency is going to be more affected by the fact that your server is 4,000 miles away in the speed of light over your optical fiber than a few nanoseconds we get from different programming language. And even then, the performance you get from your programming language is going to come far more down to your understanding and mechanical sympathy. So take one of Prime's videos the other day. He had an Advent of Code example that he went through in speeding up in Lust. I took the same example and ported it to Python. And for the first couple of Lust versions, the Python version is quicker. Now, they both have the same algorithmic complexity, but Python, you take the Python version with mechanical sympathy and it's quicker than a Lust version. So there's a lot more to performance than just your programming languages. How does it work with computer? And that's what I mentioned earlier. Intel compile engineers will build something that works far better than Intel chip because they know it inside out. They know all the tricks. And the same for performance. And when we take it to scale, most of the systems I come across, and I haven't worked at Google or any of the big tech companies, but most of the big systems I worked at multi-billion-dollar companies, the servers are over-provisioned. Most of the things are sat there idle. Whether or not the system scales is down to the architecture, down to, it processes things asynchronously. Our slow learning process is offloaded with a work queue to somewhere else. How do we recover from things? And the actual CPU on most of the boxes is sat there near idle most of the time, apart from a spike in traffic. They're not CPU bound, they're IO bound, or they're over provisioned, let's say, to cope with peaks in capacity. And it's far more about your architecture. And even just been at a multi-billion-dollar telco, one of the systems there that people are arguing about the scale, its normal throughput was 10 transactions a second.
Your Raspberry Pi could do that. Yeah.
Yeah. I mean, I've built a clone of Redis that can happily run on my little MacBook Air at 80,000 transactions a second. The reality is you can touch some very, very big websites and still have very low transactions a second. Your architecture will dominate far more than the programming language. And you should choose a programming language that fits your team, fits how you work, fits the, again, if you're doing data science, fits the libraries you've got. I mean, Python is great for that, for the availability of the libraries and machine learning or data science you've got. So there's going to be far more to it than just this doesn't scale or does scale.
So I'm going to have an answer, or I should not an answer. I'm going to have a response that's like, yes, 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 but, and here goes. When I was in school, the thing that was like kind of beat into my head, and the thing is, I don't know if this is the same experience that other people in school have today, or that the other people that are kind of like self-learning online are having today. But it was like beat into my head, Python slow, C++ fast, right? So graduating from school, I'm like going out into the workforce thinking, you got a slow system. Like, you just got to introduce some C++ there. And like all of a sudden you'll have fast system. I mean, I did understand like algorithm complexity. So like I also understood you needed to use sane algorithms for things. But after just like a year or two in the workforce, it became very clear to me that exactly like you said, 99% of the time something is slow is IO. It's like latency, physical latency from my server to my database, right? Or from my server to my user's browser. That's almost always what it is. It's like I'm waiting on IO when I shouldn't be waiting on IO. Can we do this asynchronously instead of synchronously, right? Can we do this in parallel instead of serially? And 99% of like slow problems go away there. The next 0.5% are like sleep statements that someone left in from debugging that you just need to like go remove. Go take those out. I guess you could argue those are IO. And then there's like there's like some percentage of actual performance problems left out. And I do want to point out that like, even though it might be, I don't know, I'm really hand waving here, like 1% of performance problems actually come down to like computational efficiency. If you're working on software all day, that could happen maybe once or twice a year. And I would say that's about the frequency with which I've encountered these kinds of problems. Is like a couple times a year, I need to really think about how we're doing compute, again, in the context of like backend web development. And just like an example is we had a hot path in a Ruby on Rails application where we're processing lots and lots and lots of text data from like Twitter and Reddit and YouTube, right? We're doing analysis on large amount of text and taking that hot path out and writing a little Go service to do that particular part. Again, we didn't rewrite the whole application in that moment. We just took the hot path, the part that was doing a lot of compute and allocating a lot of memory, rewrote it in Go, immediately saving tens of thousands of dollars a month across our little fleet of Kubernetes pods. I guess my point is, I'm totally with you. I think especially if you come from this same mindset that I did in school, it's very important to understand picking the programming language does not matter that much, especially for IO bound applications. But it is important to understand that when you are doing a massive amount of compute, that, you know, there is 2 orders of magnitude difference between a Go server and a Python server when it comes to just like raw computational power in like the aggregate benchmarks. I know every benchmark's different,
but again, that's going to depend. Like I say, I've got a nice example of the same code, same algorithm running in not quite the same algorithm, different implementation of the same algorithm. One in Python, one in List. The Python is 700% faster than the List.
Sorry, and I just want to make sure I'm understanding. You're saying Rust, not Lisp, right?
List, yes.
Rust, okay, cool.
Okay, and the Python is 700% faster. And it's down to the mechanical sympathy. The Python is not hitting the cache and accessing the memory in as big a space. So it is just much more mechanical empathy.
To play devil's advocate here, with Rust, you have full control. So you could literally implement the exact same program, Python interpreter at all in Rust.
That's the point of my example. You take the naive implementation of the code, and the Rust is about, as you say, twice as fast as Python. Like a performant version in Python, it's 700% faster than what looks like a good version in Rust. Translate the same thing back to Rust from Python, the Rust is about 1,000 times faster again. But if you don't have the knowledge to do that version that has mechanical sympathy, you will write slow code in any language. Somebody that knows how to write performant code will write performant code in any language. Someone that doesn't know how to write performant code will only see 10-20% speed up by switching from Python to Rust, because they still won't know all the different things that affect it. They'll still do IO at the wrong time. They'll still do too many memory allocations. They'll still not be aware of the cache and the impact of that. They'll still hit things like false sharing. They still won't write efficient concurrent code. So if you don't know how to write performant code, you can write poorly performant code in any language. If you know how to write performant code, you can write much faster code than the average in any programming language. A great example of this was a guy called Martin Thompson in 2011, I think. Started the blog Mechanical Sympathy, which is why I first heard the term, even though it dates back to the 60s. And he and his team built something they called the disruptor, and they were using that in a financial exchange. And a lot of the kind of perceived wisdom up to then is you cannot build high-frequency, low-latency trading systems in Java. It's too slow. Well, they completely blew that away by having mechanical sympathy and being aware of how it interacts with the machine.
By understanding the implementation details of the abstract system that they're using. It makes a lot of sense. I mean, if you do IO at the wrong time, like anything else you do doesn't even matter anymore. Like you already ruined it. Like if you do IO at the wrong time, you're already screwed. And it's important to understand, like when we're really talking about performance, like at a lower level, IO can just mean like going to the heap instead of the stack, right? Like you can get down really low, which caches you're hitting in the CPU, right? And so the implementation goes down even further than you might think in a lower level programming language like C or Rust, or I mean, Go is not really that low level. But another like just good anecdote around this whole idea was, I think it was the Primogen. Listeners to this pod will be familiar with him. Big Rust fan, also a Go fan, made a really interesting video where he wrote the same program in Rust and in Go. And the assumption, of course, going into the video was that the Rust version would be faster, because with the perfect implementation Rust, it should be faster, right? You can get really manual about everything and make all the optimizations. And like that holds true, but his Rust implementation was not perfect, right? And because Go and its concurrency system just made it easier to write the performant thing, at least for that particular use case. I want to say it was a web server, but I could be wrong. His Go version ended up being faster. Again, not because like Go is faster than Rust in the general case. It's really not. He wrote faster code in Go in that instance. And so I think that's what you're saying here about like, a lot of times maybe it is easier to write the Python implementation that's fast. And I don't know how often that actually is true. I'm sure it's true in some cases. And just being open-minded about that whole thing, I think is important.
Yeah, I mean, the main thing is writing performant code is a skill in itself. And if you've got that skill, you can write performant code in any language. Yes, something like Rust or C++ will be faster than Python if you have that knowledge. Most people don't have that knowledge. So learning that knowledge instead of switching programming languages would generally give you a far better outcome. And as you say, your example is great though. A lot of people say, well, it's too slow, we're going to switch language. You instead went, it's too slow, and I've identified this hot path where it's too slow, and I'm just going to fix that bit. And again, that's a skill that's missing from a lot of software engineers. Get out your tools, measure it, and then fix the bit that you can measure is the bottleneck.
Yeah, measurement is something that's overlooked so often, especially with junior engineers in my experience. Is like, if you think about software engineering as engineering, kind of insane how little we measure things, right? We write a lot of tests, but a lot of times we don't write benchmarks. And like when you're trying to figure out performance, there's just too much abstraction to not benchmark the CPU that you're running on, the virtual machine that you're running on. There's so many layers of abstraction between your code and the CPU where every instruction is being carried out. The only sane thing is if you're trying to figure out where the slow bit is to just benchmark the thing. I get that sometimes like you're looking at a like full-on algorithm and you can tell like this is like, oh, we've got a triple nested for loop, like obviously this is slow. But in the general case, when you're really trying to squeak out that bit of performance, and it's not about computer science, it's not about like the mathematical algorithmic complexity, and more about just like the real world runtime optimization, benchmarks are invaluable.
Be careful with your benchmark. I watched a team couple of years ago who are benchmarking a web service. Like, we just can't get it fast no matter what we do. When you looked at the benchmark, they were hitting it from a web server that they were using to load it, only had a limited network, and they were saturating the network. So actually, the server may or may not have been getting faster, but the thing they were testing it with was going at peak capacity and couldn't hit them any more load.
There's no
so
more
everything
bandwidth.
they did made no difference because the artificial load wasn't high enough.
That brings me to one of my biggest pet peeves, which is when a team is like working on a server or a service that like, serves HTTP requests. I should say serves responses in response to requests. And the thing they tell the world about is like, we can do 10,000 requests per second. And it's like, what does that, the only people that number means anything to you, is you guys. Because like, you're the only ones that know what happens after the request is processed, right? My Raspberry Pi can do 10,000 requests per second. Well, I don't know, something like that. If it does zero compute, right? If it just like ping pongs a message back and forth, what makes it interesting is like, what's going on behind the scenes? Are you hitting a database? Are you accessing some huge data structure in memory? Like, what's going on? So random aside, but I hate when teams publish that as like the thing to brag about.
Yeah, that's very true. And I saw the same with service a couple of years ago. So we have 2 million API requests a day. Well, what does that mean? And another team was saying, well, we can handle 10 million a day. It's like, well, again, what does it mean? But when you actually compared them, one was spread out and was, I don't know, whatever it was, like 30 requests a second. The other had 4 peak times when 500,000 requests came in within about a 10-second window. Very different usage profile and a completely different system you've got to deal with. And if you've got quiet most of the time, but then you get a massive load, it's a completely different set of engineering problems to deal with and a completely different solution. And the scale is very different then. One was smaller, but actually bigger scale.
Yeah, spiky usage, generally speaking, is a much harder problem to solve. Cool. Well, thank you so much for coming on, John. This was a lot of fun. Can you go ahead and just plug all of the places where you exist online that you want listeners to know about so they can go find you and go find your work?
Cool. Well, as you said, I'm on LinkedIn. You can find it at codingchallenges.fyi. It's the main website, and there you'll find the access to Substack there, but it's also on codingchallenges.substack.com. And I'm on Twitter, X, whatever you call it, as John Crickett. You'll find me easily enough on all of those platforms.
Amazing. Thanks so much for coming on. We'll talk to you later, John.
All right, thanks, Wayne. Thanks for having me on.